Concept 5 is all about graphing exponential and logarithmic equations. We'll do more of the transforming in class. Right now I just want you to get used to graphing them, okay? So the exponential parent function is f of x equals b to the x power, okay? If b is greater than 1, the function is an exponential growth, and is increasing forever. It always increases. If b is less than 1, the function is an exponential decay. Gosh, I can't spell. And is decreasing. Okay. All right. An asymptote, this is something you will learn about in this unit, is a line which the graph or the function gets close to but never crosses. Okay, it gets very, very close to it, but it never crosses it. Excuse me. So, sorry, I've been drinking Dr. Pepper. All right, so let's start graphing these guys. Let's see if we can't do this together. Classify as an exponential growth or decay, then graph, and then identify its key characteristics. Well, my b is greater than 1, so this is a growth function. Okay, and now we graph. So we're going to use a table of values to graph. Remember the 5 points I like to pick? This is the 5 points you're always going to use to graph. -2, -1, 0, 1, and 2. So when you graph, you want to use a minimum of 5 points, and I like to keep them around 0 because they're really, really easy to plug in mentally. Okay? If I plug in -2 for x, 2 to the -2 power, well, that's 1 over 2 to the 2nd power, because remember negative exponents flip the make it the reciprocal. Gosh, I can talk today. So this now becomes 1 over 2 to the 2nd power, which is 1/4, or 0.25 if you want a decimal. 2 to the -1 power makes it 1 over 2, so 1/2, or 0.5. Okay? 2 to the 0 power, well, anything to the 0 power is 1. 2 to the 1st power is 2, and 2 to the 2nd power is 4. So let's plot these points. So -2, 1/4 is about right there. -1, 1/2, 0, 1, 1, 2, 2, 4, and for good measure, let's use 3. 2 to the 3rd power is 8, because we can fit that on there. So 3, 4, 5, 6, 7, 8. Okay. And now we just connect. Okay. Remember, it does not cross. There is no way I can cross 0. This is going to get infinitely smaller and smaller and smaller, but I'm not ever going to cross 0. Okay. So my domain, I can plug in any value I want. It's all real numbers, okay? My range are my y values, and they always have to be strictly greater than 0. There is no value for an exponent I can plug in to make a number equal 0, which is why my y values are strictly greater than 0. Okay? End behavior, as x goes to infinity, y goes to infinity. As x goes to -infinity, y goes to 0. Not -infinity, because it can never, ever, ever cross 0. It's just going to go touch 0. It's never going to touch it even. Okay? Y-intercept, 0, 1. Okay? And my asymptote for this graph, the line that this graph gets very close to but never crosses, is y equals 0. Okay? And that's how you graph that guy. We're going to do one more together, and then we'll do the next 3 in class. Okay, so we're going to do the same thing with number 2. Is this exponential growth or decay? Well, 3 is bigger than 1, so this is also a growth. Basically, a decay is just going to look backwards. Instead of going up, it's going to come down. So, all right, let's pick some points. Probably the same 5 we were using before. -2, -1, 0, 1, and 2. Well, 3 to the negative second power is 1 over 3 to the second power, which is 1/9. If you plug that into your calculator, you're going to get 0.1 repeating, so very, very small number. 3 to the -1 is 1 over 3, which is 0.3 repeating, if you plug that into your calculator. 3 to the 0 power, anything to the 0 power is 1. 3 to the 1 is 3. 3 squared is 9. And I cannot fit any more on the graph, so let's just start graphing. -2, 1/9. This is really hard to graph, really, really small numbers. -1, 1/3. 0, 1, 1, 3, 2, 9. It's all the way up there. So this one is a bit skinnier than the last one, but it has the same asymptote. Okay. All right. My domain, all real numbers. My range is the same. Y is strictly greater than 0. As x goes to infinity, my function also goes to infinity. As x goes to -infinity, my function approaches 0. And the y-intercept is the same. And my asymptote is the same. Okay. In the next video, we'll talk about logarithmic functions.